Hi everybody, welcome back to Miss Riley's maths videos with Yoda. And what I'm going to work on here now is I'm going to work through a heap of questions on circle, perimeter, circumference and area. So I'll record a few videos and I'll do maybe 2 or 3 questions in each video and label them with that exercise number and questions. So if you're having trouble with these, or if you want to try the more challenging questions, you can try them. You can see which question I'm going to do in the video, and then you can pause the video while you make an attempt and then have a look at the video and see how it worked out. Okay, so what I'm working on now, I'm working on texts and tests 2, exercise 6.3, questions 5, 6, 7 and 8. So that's what I'll do now, if you want to find that, and then I'll work on through some of the tougher questions in that exercise. Okay, so let's start with question 5. In question 5, we're being asked to find what fraction of the area of a complete circle is each of these sectors, and we're given this one. Okay, my bad diagram. Part 2 is this one, which has 120 degrees written there. Part 3 is this one, which looks very much like the size of my other one. Just forgive my drawing. And then the last one, will I fit it over here? Sorry, Yoda, bye-bye. The last one is here. Okay, so page, I didn't say the page number, page 119, exercise 6.3. So the first question is, what fraction of a complete circle? Okay, and if you remember in our other videos about a perimeter and circumference and area of a circle, we said that it's the size of the angle over 360 degrees, and we talked about that angle as being angle theta, if you remember that, over 360 degrees. So what we need to do to decide what fraction of a circle we have is to put the angle at the center over 360 degrees. So this is a right angle, as you know. So the fraction of a circle here is 90 out of 360, which is 1/4. This one here, part 2, is 120 out of 360, which is 1/3. The next one is 60 out of 360, which is 1/6. And the last one is 45 out of 360, which equals what's that? 1/8, is it? 1/8. So that's the fraction of the circle that we have. Next one says, find the length of the arc AB in these sectors. Well, what I'm just going to do is let's just leave that. So that's question 5. Hopefully that's quite straightforward for you. Okay, question 6 then. I actually thought they'd asked us to do more in question 5, but they haven't. So question 6 says, find the length of the arc AB. So let's just draw these for a moment. I'll just pause the video while I draw this. Okay, so I'm back again. I know that didn't pause for you, but anyway. So here we have 3 bits of a circle, and the question is, find the length of the arc. Find the length of the arc AB in each circle, or in each sector. So just a quick reminder that a sector is a section of a circle. It's a part of a circle, like a piece of pizza or a piece of cake. And we've got to take pi equal 3.14 and give your answer correct 2 decimal places. So reminder that the length of a circle equals 2 pi r. So we've got a bit of a circle, and if we had the whole circle, it would be 2 pi r. So that would be the whole circle length. Okay, so let's take this one here. So what we've got to find out is, what's the angle? The angle is 90 degrees. So how much of a circle? We've got 90 out of 360, which is 1/4. Okay, let's just move up a bit here. Okay, 90 out of 360, which is 1/4. So a full circle would be 2 pi r. So 1/4 circle will be 1/4 by 2 pi r. Now what's the radius? The radius in this case is 21 centimeters. So the length of arc AB, which remember the arc AB is this bit. Okay, length of arc AB, that's what they're referring to as that bit, is equal to 1/4 by 2 by pi by 21. But they've told me to take pi to be 3.14. So 1/4 by 2 by 3.14 by 21. Let's just work out what that is on the calculator. So 1 divided by 4 equals by 2 by 3.14 by 21 equals, and to 2 decimal places, it's 32.97. 32.97 centimeters. Okay, let's take the next one. The angle is 45 degrees. So how much of a circle? It's going to be 45 out of 360, which we decided was 1/8 a few moments ago. So a full circle equals 2 pi r. 1/8 of a circle will be 1/8 by 2 by pi by r. The radius is 14 centimeters and pi is 3.14. So the length of arc AB, again, AB is this arc here. So the length of arc AB is going to be 1/8 by 2 by 3.14 by 14. Okay, 1/8 by 2 by 3.14 by 14. So 1 divided by 8 by 3.14 by 2 by 14, which is 10.99 centimeters. Okay. Here we've got an angle of 120 degrees. So how much of the circle is that? That's 120 over 360, which is 1/3. So the length, let's just skip on a bit quicker. The length of the arc AB, again, we're talking about this length here. Length of arc AB is equal to 1/3 by 2 by pi by r. R is equal to 28 centimeters. Pi is equal to 3.14. So 1/3 by 2 by 3.14 by 28. And again, we'll plug that into the calculator. 1 divided by 3 times 2 times 3.14 times 28 equals 58.61 centimeters. Okay, hopefully that makes sense to you. Just checking that's in focus. Okay, now question 7 then asks us to find the area of those. So let's try and find the areas down here under our diagram. So now we're trying to find the area of the sector. So the area of the sector area is pi r squared. So in this one here, we've got 1/4 of a circle. So 1/4 times pi by r squared. So 1/4 by 3.14 by 21 squared, which is equal to 0.25 times 3.14 times 21 squared, which equals 346.19. 346.19 centimeters squared. It was 0.185, but we rounded it up to 2 decimal places. Okay, here we've got 1/8 by pi r squared. There's the 1/8. Okay, so 1/8 by 3.14 by 14 squared. 1 divided by 8 times 3.14 by 14 squared equals 76.93. And question 8, we've got 1/3. 1/3 by pi r squared. So 1/3 by 3.14 by 28 squared. So 1 divided by 3 by 3.14 by 28 squared equals 615 as a decimal, 820.59 centimeters squared to 2 decimal places. Okay, I hope that makes sense. So in that case, we've got those are the areas that we've just worked through. Chisel highlighter, here we are. Okay, so this is the area for those. Okay, hopefully that's helpful. So that's 5, 6, 7, and then finally question 8, find the perimeters. So turning over the page, and I'll just pause while I draw the diagrams. So in question 8 on page 119, we're being asked to find a different answer. We're being asked to find the perimeter of these shapes. Now, if you remember, a moment ago we were finding the arc. So the arc of this shape would be this bit. Okay, it would be the roundy bit. It's the part of the circle that, the part of the roundy bit of the circle that we have out of this half circle that we have. The perimeter is different. The perimeter is going to be the distance all the way around here, but then also along here and along here. So the perimeter is the roundy bit, and it's the straight bit as well. So it's the distance that we would walk if we walked around the full shape. So to find the perimeter, we're going to do 2 bits. We're going to find, first of all, the arc length. Okay, so the arc length, the fraction of the circle, well, it's a semicircle, so it's 180 degrees out of 360, which is 1/2. It's a semicircle, so it's going to be 1/2 by 2 pi r, which is going to be 1/2 by 2 by 3.14. Now, the diameter is 28, so the radius is 14. So it's 1/2 by 2 by 3.14 by 14. 1/2 by 2 by 3.14 by 14, which is 43.96. So that's the arc. Now, to travel the full perimeter of this shape, here I am, I'm starting here. This is my arc, which I've just found now to be 43.96. But I've got to add on this straight bit now, plus 28. So plus 28 centimeters for the diameter, which is what, going to be 71.96 centimeters. So the perimeter of the shape equals 71.96 centimeters. Okay. You try this one now, pause the video, you try and do this, and then come back and look at the solution. Okay, so let's look at it here. We've got the arc first of all. So there's the arc. We've got arc length. Here the radius is 14, and it's 60 out of 360, so it's 1/6 of a circle. So it's going to be 1/6 by 2 by pi by r. So 1/6 by 2 by 3.14 by 14. That's a bit weird, isn't it? That it's 14 again, and that was 28. But anyway, 1 divided by 6 equals, I know you can't see that very clearly, by 2 by 3.14 by 14 equals 14.65. 14.65 centimeters for the arc. Okay, and then I've got to add on. So here's my, starting here, I go down here, and then I go up here and up here. So I've got to add on 14 for this radius, and then 14 for that radius, because they're both radiuses. They have this little notch on them to show they're the same length. So this is also 14. So 14.65 plus 14 plus 14. So what's that going to be? That's going to be 42.65 centimeters for the perimeter. Okay, perimeter. Hopefully you got that. Now try the last one, and then I will work it through. Okay, so here we have the arc length. It's a very big arc length now here, because we've got a 90-degree angle, which means that this is 270. So we've got 270 out of 360, which, as you've guessed, we've got 3/4 of a circle. So the arc length is going to be 3/4 by 2 by pi by r, 3/4 by 2 by 3.14 by 7. So 3/4 times 2 times 3.14 times 7. So 32.97 centimeters for the arc length. Okay, and then the perimeter is going to be here, start here, go around, go around, go around, go around, and then down and along. So I have to add on this 7 and this 7. So what's that going to be? 46.97 centimeters for the perimeter. Okay, I hope that's making some sense. Message me if you're not sure about it.